The topic is the greatest common factor and factoring by grouping. The first objective in this topic is identify the greatest common factor, GCF. What are some ways that we can multiply two numbers together, two positive numbers, and get 12? 1 times 12. 2 times 6. 3 times 4. We already have 4 times 3. We already have 6 times 2. We already have 12 times 1. These are called factors of 12. They are numbers that you can multiply by other numbers in combination to get 12. Pairs of factors are specific pairs that multiply to 12. 1 and 12, 2 and 6, 3 and 4. This comes from the fact that, for instance, in the multiplication problem, 2 times 6 equals 12. 12 is called the product, and 2 and 6 are called factors. We deal with factors a lot when we're talking about reducing fractions. Recall that to reduce the fraction 16 over 24, one method we have is to create factor trees and find the prime factorization. In other words, breaking it down until all of the factors listed are prime numbers. So maybe 16 breaks up as 4 and 4. 4 breaks up as 2 and 2. And then in the end, we can say that 16 is 2 times 2 times 2 times 2. 24 could be 4 times 6. 4 is 2 times 2. 6 is 2 times 3. 24 is 2 times 2 times 2 times 3. So 16 over 24 can be rewritten as 2 times 2 times 2 times 2. 24 has 2 times 2 times 2 times 3. And then we can cancel pairs of 2's, and we're left with 2 over 3, 2/3. And that's one way to reduce fractions. Now, what actually canceled away here was one set of 2's, one set of 2's, and one set of 2's for 3 sets of 2's total. In fact, 1, 2, 3 sets of 2's are what we have in common to 16 and 24. 2 times 2 times 2 is 8. We call 8 the GCF, the greatest common factor of 16 and 24. Another way of finding greatest common factor of 16 and 24 would be to list all of the factors of 16, just like we did for 12. 1 and 16, 2 and 8, 4 and 4. For 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. 1, 2, 4, and 8 1, 2, 4, and 8, they are common factors to 16 and 14, but what is the greatest common factor? What is the biggest number in both lists? 8, greatest common factor. We can extend this to variables. If we had x to the 5th and x cubed, x to the 5th is x times x times x times x times x. X cubed is x times x times x. What's in common? 1, 2, 3 pairs of x's. X times x times x is x cubed. So x cubed would be the GCF of x to the 5th and x cubed. In general, the rule we'll have is if we have the same variable, then the greatest common factor is going to be the lowest power shown. So for x to the 5th and x cubed, it's the same variable. The greatest common factor is going to be x to the lowest power shown. 3 and 5, what's the lower number between those two? 3. If we put these two things together, how to find greatest common factor of variables, lowest power shown. How to find greatest common factor of numbers, take the prime factorizations. Everything that's in common is a part of the greatest common factor. We could find greatest common factor of things like this. Let's find the greatest common factor of 12x to the 5th, 18x to the 4th, and 24x cubed. If we did a factor tree for the prime factorization of 12, 12 is 3 times 4, 4 is 2 times 2. 12 would be 2 times 2 times 3. 18. 2 times 9. 9 is 3 times 3. That means 18 is 2 times 3 times 3. 24. 4 times 6. 2 times 2. 2 times 3. 24 is 2 times 2 times 2 times 3. What's in common to everything? Well, we got some 2s. Looks like we got 3s. Nothing else in common to all three things, just a 2 and a 3. What about the variables? X to the 5th, x to the 4th, x cubed. They all have x's. The lowest power shown, 5, 4, and 3, is 3. 2 times 3 is 6, so 6x cubed would be the GCF of 12x to the 5th, 18x to the 4th, and 24x cubed. What we're going to do now is a process called factoring out the greatest common factor. The second objective in this topic, factor out the greatest common factor of a polynomial's terms. First step, of course, would be to find the greatest common factor, which we just did. The problem we're going to look at, we're going to start with 12x to the fifth plus 18x to the fourth minus 24x cubed. Factoring out a GCF is basically doing the distributive property in reverse, backwards distributive property. So first we find the GCF of each term. 12x to the fifth, 18x to the fourth, 24x cubed, and we just found that. It was 6x cubed. By the way, the other way of finding the GCF of 12, 18, and 24 is make the lists, find that 6 is the biggest number in all three lists. When the numbers are relatively small, you can do it that way, but as we start dealing with larger numbers, it's going to become easier just to do the prime factorization method every time. So I keep saying, I've said it a couple times now, distributive property backwards, distributive property in reverse. What does that mean? Well, this is 1, 2, 3 terms. So our leftover piece is also going to be 1, 2, 3 terms. 1, 2, 3. Hopefully now you're seeing distributive property in reverse. 6x cubed, what would go here to give us 12x to the fifth? 6x cubed times 2x squared would be 12x to the fifth. Now you're seeing why we did work with exponents, why we learned these rules. We need them to be able to factor. And just to check, 6x cubed times 2x squared, 12x to the fifth, yep. Next, 6x cubed times what is 18x to the fourth? Well, positive 6 times positive 3 gives us the positive 18. X cubed times x would give us x to the fourth. 6x cubed times what is negative 24x cubed? Well, positive 6 times negative 4 gives us the 24, and we already have all of our x cubed. So let me bring that parenthesis in a little bit. And that is what we get when we factor out the greatest common factor. 6x cubed times the trinomial, 2x squared plus 3x minus 4. We can always check our work when we factor, because factoring is the reverse process of multiplication. That's why it was distributive property in reverse. If we multiply our factored form, we should get what we started with, and we do. (24) s cubed t squared plus 8 s t to the fourth minus 12 s to the fifth t. Let's factor out the greatest common factor. 24 8, and 12. The greatest common factor would be 4. S is in all three of these. The lowest power shown is S to the first. T is in all of these. The lowest power shown is T to the first. So 4ST would be the greatest common factor of 24S cubed T squared, 8ST to the fourth, and 12S to the fifth T, or negative 12S to the fifth T. 1, 2, 3 pieces in the original. So 1, 2, 3 pieces in the leftover. 4 times what is 24? 4 times 6. S times what is S cubed? S squared. T times what is T squared? T. You can see why it has to be the lowest power shown, because we're going to be multiplying up to get to what we started with. And just check now, 4ST times 6S squared T, 24S cubed T squared. 4 times what is positive 8? 4 times positive 2. S times what is S? We don't need any more S's. T times what is T to the fourth? T times T cubed. Just check, 4ST times 2T cubed, positive 8S T to the fourth. We're good there. 4 times what is negative 12? 4 times negative 3. S times what is S to the fifth? S to the fourth. T times, we already have all the T's we need. So just checking, 4ST times negative 3S to the fourth, negative 12S to the fifth T. That's our factored form. Looking in the leftover piece, there is nothing else that we can factor out. So this is completely factored. That means that is our final factored form. 3y times 2y minus 5 plus 2 times 2y minus 5. This looks completely different than what we were just doing. But there is a common factor. How many terms do we have here? It's only 2. This 3y times 2y minus 5, it's 2 things multiplied together. We are taking that and we are adding this thing, 2 times 2y minus 5. 1 term, 2 terms. What's the common factor? Well, we literally see it. The common factor here is this 2y minus 5. It is in common to both. It is the common factor. It is literally a factor in common to both terms. What do we do with it? We factor it out. Factor out the greatest common factor. There it is. When we factor out the greatest common factor, what do? The distributive property in reverse. We started with 2 terms, so our leftover piece is going to have 2 terms. that's the dead one. Watch this. This times what is that times that? That times that is that times that. Literally, that times that is that times that. This times what is this times that? Literally, positive 2. This times that is this times that. Hope you see how we did the distributive property in reverse here. 2y minus 5 times what is 2y minus 5 times 3y? 3y. 2y minus 5 times what is 2y minus 5 times positive 2? Positive 2. So that's the factored form, the final answer, 2y minus 5 times 3y plus 2. Factored form is allowed to be written in either way. Why? Well, because a times b is the same as b times a. That's the name of the game. That was an ABBA joke. Okay. So we can switch the order. This could also be written as 3y plus 2 times 2y minus 5. These both mean the same thing. I'm going to do that same problem. I'm going to change it up a little bit. Move it in and make them x's so that we're sure that it's different. 3x times 2x minus 5 plus 2x minus 5. So last time we had 3y times 2y minus 5 plus 2y times 2y minus 5, or times 2. My point is, in the last problem, we had a number out here, like 2. We don't have a number here this time. So let me do this the same way. I'll use the same color coding. The common factor is 2x minus 5. So that's going to get factored out. 2 terms means 2 terms in the leftover piece. Two x minus 5 times what is 2x minus 5 times 3x? That's 3x. Now, 2x minus 5 times what is 2x minus 5? 2x minus 5 times 1. Not just any kind of 1. Positive 1. 2x minus 5 times 1 is 2x minus 5. We can imagine that when we have plus this thing in parentheses, we have plus how many? Plus 1 of these things in parentheses. If we write in the imaginary 1, then to get this leftover piece, we could just do 3x plus 1, 3x plus 1. And we get that as the answer. Let's do another like that. I'm going to stop the color coding. (5w times w minus 3) minus, in parentheses, w minus 3. The common factor is w minus 3. We take that out. We have our imaginary 1, 5w minus 1. That's it. Doing all that color coding was just making it more complicated in terms of what I'm writing. But the common factor gets factored out, and then what's left over is right there. This is going to be the basis of something called factoring by grouping. So today we're looking at greatest common factor and factoring by grouping. Before we get fully into the factoring by grouping, let's look at a very specific direction, and then we'll move on. Factor out -4 from the polynomial -4x squared minus 8x plus 12. Here we are specifically told to factor out a -4. That means we don't have to worry about looking for the GCF or anything like that. We're just told, hey, factor out a -4. So if a -4 is coming out, we need to think about the distributive property in reverse to find out what the 3 terms in our leftover piece will be. 3 terms in the leftover piece because 1, 2, 3 terms in the original. -4 times x squared is -4x squared. -4 times positive 2x is -8x. And -4 times positive 3. No, not positive 3. Negative times negative is positive. So -4 times -3 is positive 12. All we're doing is thinking about the distributive property. What would we have to get us what we're starting with? Factoring out a -4 means a -4 is on the outside. We imagine what would we have to be distributing through to get us what we're starting with. The third objective in this topic, factor polynomials by grouping. Let's start with a multiplication problem. 3a plus 2 times 2b minus 7. We know how we would do this. We FOIL. 3a times 2b would be 6ab. 3a times -7, -21a. Inner 2 times 2b, positive 4b. Last, positive 2 times negative 7, negative 14. So when we multiply this, we get to here. That means that we are going to have a method of factoring this that would give us what as an answer? Factoring is going the opposite direction of multiplication. So if this is what we get multiplying this way, then going the other way would be factoring. This factors to 3a plus 2 times 2b minus 7. Now let's find out how to do it. Let's start with 6ab minus 21a plus 4b minus 14. Let's factor, see how we get to our answer. So first of all, the first rule of factoring any problem is look and see if there is a GCF to factor out. It has to occur in all 4 terms. 6, 21, 4, and 14 do not have any factors in common. To see that, 21, the prime factorization would be 3 times 7. These ones wouldn't have a factor of 3. These ones wouldn't have a factor of 7. There is not anything that's going to be able to come out of all 4. We can't take out any A's because the A's are only in these 2. It would have to be in all 4. We can't take out any B's because the B's are only in these 2. It has to be in all 4. So there is no GCF to take out of everything. When we have 4 terms, that screams do factoring by grouping then. If you can't take something out of everything, we're going to do this grouping method. The grouping method says always group the first 2 terms and ignore the rest. Do not put parentheses around the second 2. It's not the method we are doing. So just put parentheses around the first 2 terms. Ignoring the rest, can we factor something out of this? Absolutely. 6 and 21 have a greatest common factor of 3. Both of these don't have B's, but they both have A's. The lowest power of A shown is a to the first. We're just factoring out of these first 2 terms. Again, we're ignoring the rest for now. They don't exist. La, la, la. 3a times 2b would be 6ab. 3a times negative 7 would be negative 21a. Now, that's the beginning of factoring by grouping. Group the first 2 terms, ignore the rest, factor your greatest common factor out of just those 2 terms. Now we're going to ignore this part and we're going to come over here. Whatever comes next, plus or minus, we have to put that sign here. Since this is a plus, we have a plus. Whatever we factor out has to be positive because of that plus. 4b and 14 have a greatest common factor of 2. No variable, just 2. Can't take out any b's because they both don't have b's. Now here, positive 2 times what is positive 4b? Positive 2 times 2b. Positive 2 times what is negative 14? Positive 2 times negative 7. Now, If you've done factoring by grouping correctly, the end result is supposed to be that our leftover piece was exactly the same. And lo and behold, the leftover piece is exactly the same. Yeah. What are we factoring out? That greatest common factor of 2b minus 7. What are we left with? Our leftover piece of 3a plus 2. And that's our answer. And like I said, we can switch the order of these two things and get 3a plus 2 times 2b minus 7. Got the answer we wanted. Let's do some practice with factoring by grouping. Let's take a look at 7c squared plus cd plus 14c plus 2d. Group the first two. We can factor out a c. We're left with 7c plus d. Group the first two terms, ignored the rest. We only have a c in common. Take the c out. C times 7c is 7c squared. C times d is cd. We're following it up with a plus, so we bring down a plus. Whatever we factor out must be positive. Can't factor out any c's, can't factor out any d's because they don't exist in both. But 14 and 2 have a greatest common factor of 2. Leftover piece of two terms. 2 times 7c would be 14c. Positive 2 times positive d would be positive 2d. Leftover piece exactly the same, so we did good, kid. 7c plus d, and what are we left with? C plus 2. How can we check factoring? We can check factoring with multiplication. FOIL, 7c times c is 7c squared. Outer, 7c times positive 2 plus 14c. Inner, d times c plus cd. Last, 2 times d plus 2d. 7c squared plus 14c plus cd plus 2d. Those are our 4 terms. We got it right. We could have also had c plus 2 first and 7c plus d second. Let's take a look at x cubed plus 3x squared minus 3x minus 9. There does not exist a greatest common factor of all 4 terms to take out. This one doesn't have any coefficients. That one doesn't have any x's. So we are forced to turn to factoring by grouping. Group the first 2 terms. What can we take out? X squared. What are we left with? X squared times x is x cubed. X squared times positive 3 would be 3x squared. After this grouping, we have a minus. Bring it down. Whatever we factor out next must be negative. Be careful with your signs. 3x and 9, we have a common factor of 3, so we're taking out a negative 3. Again, be careful with the signs. Negative 3 times what is negative 3x? Negative 3 times x. Negative 3 times what is negative 9? Negative 3 times positive 3 is negative 9. Negative 3x minus 9. Good. And leftover piece is exactly the same as we wanted. Factor it out. X squared minus 3 is what we're left with. X plus 3 times x squared minus 3. Let's do it again. Practice, practice, practice. A cubed minus 4a squared minus 3a plus 12. We don't have a's in all four terms. We don't have any coefficient here. Nothing we can take out of all four. So we have to do factoring by grouping. Group those first two terms. A cubed and a squared both have an a. Lowest power shown is a squared, so out it goes. A squared times a would be a cubed. A squared times negative 4 would be negative 4a squared. This grouping is followed with a minus. Bring the minus down. Whatever we factor out next will be negative. 3a and 12, all that is in common there is a 3. So we're factoring out a negative 3. Negative 3 times a is negative 3a. Negative 3, be careful, times negative 4. Negative 3 times negative 4 is positive 12. Leftover piece is the same. It's the greatest common factor now. Factor it out. And what are we left with? A squared minus 3. Now let's take a look at 24 p squared q squared minus 18 p squared q plus 60. I'm going to run out of room. Let me rewrite this. I didn't screw anything up, so you're good. I just need a little bit more space. 24 p squared q squared minus 18 p squared q plus 60 pq squared minus 45 pq. An interesting thing happens here. What's that first thing I've been doing? I've been checking for a GCF, but there hasn't been one, which has forced us to just start with the grouping. But here, 24, 18, 60, and 45, they do share factors. Specifically, if we had our lists of 24, 18, 60, and 45, highest number in common to all four, yeah, there'd be a number in common to all four, it would be 3. 3 is a factor of all of these. In fact, it is the greatest common factor of these. So we'll factor out a 3 overall. All four terms have p's. So we can take out a p to what power? To the lowest shown power. P squared, p to the first, Lowest shown power is just p to the first. Q. Q's in all of them. Q squared, Q, Q squared, Q. Lowest power of Q is just Q to the first. So we're going to think about the distributive property with 4 terms. 3pq times what is 24p squared q squared? 3pq times 8pq. This is why it's important to have your exponent rules down. Three pq times what is negative 18p squared q? 3 times negative 6 is negative 18. P times p is p squared. Q times, we already have all the q's we need. 3 times positive 20 is positive 60. P times, we already have all of our p's. Q times q is q squared. 3 times negative 15 is negative 45. We already have our p's. We already have our q's. So if you want to double check that this distributed through everything gives us this, you can. But we're not done. We factored out the greatest common factor, but the stuff that's left, we need to factor by grouping. So don't forget that you have this 3pq. It's going to be out in front of every step from here to the end, all the way up to and including our answer. In the meantime, if we look in here, I want to group these first 2 terms, 8pq minus 6p. I'm not going to group the rest. We know how to handle that when we get there. 3pq. What can we factor out of these? 2p. What are we left with? 4q minus 3. 2p times 4q is 8pq. 2p times negative 3 is negative 6p. Plus, so we're going to factor out something positive. 20q and 15. We can take out a positive 5. 5 times what is 20q? 5 times 4q. Positive 5 times what is negative 15? Positive 5 times negative 3 is negative 15. There's the greatest common factor. So we have our 3pq, then times this factored out 4q minus 3, and then our leftover piece, 2p plus 5. And that's our answer. So again, this looks more complicated because we had a greatest common factor that we factored out first, that 3pq. But if you ignore that 3pq, this is no different than the last few examples we've been doing with factoring by grouping. It's just that when we get our answer, 4q minus 3, 2p plus 5, we want to make sure that GCF we factored out is in the front as well. Sometimes the factoring by grouping is not given to us in the best order. For instance, let's say we had 4x plus 6pa minus 8a minus 3px. Nothing that we can take out of all four. 4, 6, 8, and 3 don't have a factor in common to all of them. We don't have x's in everything. We don't have p's in everything. We don't have a's in everything. 4 terms, nothing comes out. Factoring by grouping is the only way to go. If I group these first two, all I can take out is a 2. And I'm left with 2x plus 3pa. Minus absolutely nothing can come out. 8 and 3, no a, no p, no x. So I'm just factoring out a -1. And I'd have 8a plus 3px. These leftover pieces aren't the same. We can't factor it out. I don't know what to do. This tells us that this can't be our grouping. We have to start over. It will then become our strategy to regroup, rearrange before doing our groupings. Let's get some common variables together. What if this x was with that x? So 4x minus 3px plus 6pa minus 8a. Let's try that. Let's see if that works. Well, now here I can take out an x, and I'm left with 4 minus 3p. Over here, I can factor out a 2a, and I'm left with 3p minus 4. Close, no good. Still doesn't match. I think I could get a match if these two were switched, though, because I would like these to be switched. So one more time. (4x minus 3px). Let's go minus 8a plus 6pa. One of these will do something for us. If we group here, I can take out an x. I'm left with 4 minus 3p. Here, minus, taking out a negative. Negative what? I can take out a 2. I can take out an a. Negative 2a times positive 4 is negative 8a. Negative 2a times negative 3p is positive 6pa. Boom, we got it. Took a bunch of rearranging, but we finally got one where when we do the grouping, we get the same leftover piece. Factor that out. Factor out the 4 minus 3p. We're left with x minus 2a. Bingo, bango, and bongo. That's our answer. or minus 3p times x minus 2a. And there's another way we could have rearranged it where we would get them in the other order. Houston, we have a problem. We have nothing in common in the first two terms. We have nothing in common in the second two terms. And the two terms don't have any common binomial factors, so we can't factor anything right now. Remember what the steps said, though. If we run into this exact situation where nothing can be factored out of our groups, rearrange the terms so that they can. A way that does work is to group the 3xy with the minus 3x because of that obvious 3. And then we'll give ourselves a plus sign to add the other two terms that are left, the negative 2y plus the 2 because of the obvious 2. And the reason that I put them in that order with the negative 2y first and then the 2 is that looking at the first grouping, it's the first term that had the y. So remember, we're trying to get things to match up. So we're placing things where they might be useful. From the first group, the 3xy minus 3x, we can factor out a 3x. From the second group, we can see that we can factor out a 2, but we're going to want to factor out a negative 2. Because whenever we can factor out a negative and make our variable positive, we want to do that. Not to mention, it's going to be the only way to get them to match. So we factor out our 3x and we're left with y minus 1. We factor out our negative 2 and we're also left with y minus 1. You might be thinking, y minus, where did the plus go? Well, again, we factored out a negative 2, and negative 2 has to be multiplied by negative 1 to give ourselves positive 2. So when we set up the leftover piece, when we think about the distributive property in reverse, we have to account for our signs. But now we can factor out a y minus 1, and we're left with 3x minus 2. And that is it for this topic. The topic is factoring trinomials. The first objective in this topic is factoring trinomials of the form x squared plus bx plus c. Remember, factoring and multiplication kind of undo each other. If we had two binomials, like x plus 2 times x minus 3, and we were asked to multiply, what would we do? We would FOIL. First, outer, inner, last. X times x is x squared. X times negative 3 is negative 3x. Positive 2 times x is plus 2x. Positive 2 times negative 3 is negative 6. Combine like terms. Negative 3x plus 2x would be negative 1x. We just write that as negative x minus 6. So x squared minus x minus 6 is what we get when we multiply x plus 2 times x minus 3. So factoring is the reverse of multiplication. So if we were asked to factor and we were given x squared minus x minus 6, the answer would be x plus 2 times x minus 3. What we're going to do today is we're going to see the process that takes us from that to that as we learn how to factor trinomials. We're going to factor 3-term things. So, the first thing we're going to do is look at trinomials in this form. X squared plus bx plus c. So no coefficient, well, a coefficient of 1, no visible coefficient on the x squared. That would be something like this. And I'm going to go ahead and just erase that for now. Our strategy, when we see this form, we have the x squared, nothing in front. Our strategy is going to be find the numbers that multiply to give us b, or sorry, multiply to give us c and add to give b. Well, what do I mean by that? Let's take a look at x squared minus x minus 6. Here, b would be negative 1. C would be negative 6. B being the coefficient of x, negative 1. C being the constant, negative 6. We would want to find two numbers that multiply to give us negative 6, add to give negative 1. So what are the different factors of 6? Well, we have 1 and 6. We have 2 and 3. Since it needs to multiply to be negative, one of them needs to be positive, one of them needs to be negative. They need to add to give negative 1. So if we add them, positive 1 minus 6, that's negative 5. Positive 2 minus 3, wow, second one we tried. Positive 2 minus 3 is negative 1. If I were to finish this, negative 1 plus 6 would be positive 5. Negative 2 plus 3 would be positive 1. And we see each set, positive 1 times negative 6, positive 2 times negative 3, negative 1 times positive 6, negative 2 times positive 3. They all multiply to give negative 6. But the one that multiplies to negative 6 and adds to negative 1, those are what we're going to use in our factoring. Since it's an x squared, The only way we can get that is x times x. And then these numbers we found, positive 2 and negative 3, we just put them right in. And that's the answer. So that's how we factor when it's in this form. Let's do another. X squared minus 6x plus 8. We would need numbers that multiply to give the constant, multiply to give positive 8, add for the number in front of x, add to negative 6. So the sign is important. So what are our numbers that multiply to positive 8? Well, the numbers that multiply to positive 8 would be 1 and 8, 2 and 4. But it's not just positive numbers. Remember also that a negative times a negative also is positive. So these are all the combinations that multiply to give positive 8. If we add them, we're looking for the one that would add to be negative 6. 1 plus 8 would be positive 9. 2 plus 4 would be positive 6. Negative 1 minus 8 would be negative 9. Negative 2 minus 4, that one's negative 6. This is the pair that multiplies to positive 8, adds to negative 6. So our numbers that we're going to use in our two binomials that have x and x are going to be negative 2 and negative 4. That's it. How can we check? Well, we could always check our factoring with multiplication. So if we FOIL, x times x is x squared, x times negative 4 is negative 4x, negative 2 times x is negative 2x, negative 2 times negative 4 is positive 8, and when we combine like terms, x squared minus 6x plus 8. So right off the bat, this looks different. We're using m instead of x, but that's not the big difference. This has a 3 in front of the m squared. It's not in the form m squared plus bm plus c. It's an am squared. So we would need a method for factoring something of that form, except for the fact that we can actually factor a 3 out of this. The very first rule of factoring that we learned was GCF. And the reason we learned it first is because we always do it first. If we can factor out a GCF, we must do so. So let's factor that 3 out. The leftover piece is going to have 1, 2, 3 terms. 3 times what is 3m squared? M squared. 3 times what is negative 24m? Negative 8m. 3 times what is negative 60? Negative 20. So now we do have something in the form that just has a 1 m squared. We can factor this. Let's look for numbers that multiply to negative 20 that add to negative 8. Well, let's see. They're adding, or they're multiplying to a negative, so they must have two different signs. +20 and 1 plus 20 minus 1, that's 19. And the other way would give us negative 19. 5 and 4. 5 and negative 4, that's 1. And 4 and negative 5 is negative 1. We need negative 8. 10 and 2. 10 and negative 2. Well, 10 and negative 2 is positive 8, but if we switch it, negative 10 and positive 2, that is negative 8. So negative 10 and positive 2 are the numbers that we put in our parentheses along with our m's.